Great. On Friday, we talked about covering a filing cabinet with sticky notes. So at the very top, it says that to watch the video showing a cabinet that is partially covered with Post-it notes. The link for that will be the first link that I put in eBackpack. The second link will be the link to this video. And it's just asking us to estimate how many Post-it notes we think would cover the entire filing cabinet. So what I'm asking you to do is watch the video and then make an estimate based on how many Post-it notes you think it will cover the front side of the cabinet, the back side of the cabinet, the left side, the right side, and the top. We cannot put Post-it notes in the bottom of the cabinet because the bottom of the cabinet is on the floor. The second question asks us to look at that filing cabinet and go along with it. So the thing about the video is that it doesn't tell us all the dimensions that we need in order to find the surface area or find out how many Post-it notes cover the entire filing cabinet. So what we need to do is we need to find the area of each side of the filing cabinet. We need to find the area of each side of the filing cabinet. So if you think about a filing cabinet, from the filing cabinet, it is a rectangular prism. A rectangular prism has 6 faces. It has a front, a back, a left side, a right side, a top, and a bottom. So this right here is what we're talking about. This is a rectangular prism, and so when we say it has 6 faces, it has 1, 2, 3, 4, 5, 6. And so to find the area of each side of the filing cabinet, each one of these faces is a rectangle. So we know how to find the area of a rectangle. Finding the area of a rectangle is base times height. So to be able to calculate this, we'd have to find the area of each side and then add them all together. So we need to find the area of each side of the filing cabinet, excluding the bottom. And add them together. The needed information, what we need to know is measurements of the cabinet. And the area that the sticky notes take up. So we're going to use information to be able to find sort of the surface area using sticky notes. So we're finding, sticky notes here. So we know that I covered our filing cabinet in our classroom, and so we have a couple of dimensions. We have 12, 26, and 6. These are our 3 numbers that we're going to use. Now the front side of the cabinet is 12 across at the top and 26 down the side. So that rectangle there would be 12 times 26. So I'm going to do that calculation. 6 times 2 is 12, 6 times 1 is 6, plus 1 is 7. Add a placeholder, 2 times 2 is 4, 2 times 1 is 2. So for the front side of the cabinet and sticky notes, I get 312 sticky notes would cover that entire front cabinet. Now since there's a front and a back to a rectangular prism, that means they're going to have the same exact area. What I'm going to do is I'm going to double this number. So I'm going to take 312 times 2. That's going to give me 624. Okay, so that's the front side of the cabinet. Now this back side here, that missing dimension that we need to solve this goes back 6. So for this side and the opposite side of that, we're going to do 6 times 26. 6 times 6 is 36. 6 times 2 is 12, plus 3 is 15. So I'm going to get 156, and because I have a left side and a right side, I'm going to double that as well. It's going to give me 312. So I'm going to add these two numbers, but I have one more number. So the top of the filing cabinet is 12 by 6. So I'm going to do 12 times 6. 12 times 6 gives me 72. And there's only one side of that because the bottom is excluded. So now what I'm going to do is I'm going to add 624, 312, and 72 to find my answer. So it should be 624 plus 312 plus 72. 4 plus 4 is 8. 7 plus 3 is 10. 6 plus 4 is 10. 1008 sticky notes are going to cover that the filing cabinet in our room. And so basically the concept that we're looking at is we're finding the area of each side, right? Each side of a rectangular prism, and that is calculating surface area. Right, moving forward. On this page here, it says, here's a sketch of a rectangular prism built from 12 cubes. It has 6 faces, but you can only see 3 of them in the sketch. It has a surface area of 32 square units. So this is where we play with snap cubes. You have 12 snap cubes from your teacher. Use all the snap cubes to build a different rectangular prism with different edge lengths than shown in the prism here. So what I'm going to do is I'm going to get some snap cubes. So give me a second. So getting some snap cubes, so we want to build a different rectangular prism than the one shown in the picture because we want to be able to see if we can find out the surface area. So this one I'm going to do, let's see, I'm going to do a 2 by 6 because 6 times 2 is 12, and then work from there. Right, so I've built a different rectangular prism. There's a total of 12 cubes. Now we're asking the first test, so how many faces does this figure have? Well, there's 1, right? 2, 3, 4, 5, and 6, because a rectangular prism has a top, a bottom, a side, a front, and a back. Right? It depends on the view that you're looking at, but it has 6 faces. So we have 6 faces. Now, they tell us that this has a surface area of 32 square units. So what is the surface area of our figure? To find that out, we're going to have to look at each side and then basically double how many square units we have. So on this side, I have 6 by 2. 6 times 2 equals 12, and we're going to double that because the back side, right, should be the same. So if I flip this over, there's 12 on that side as well. So 12 times 2 is 24. So that's one part of my answer, right? Now I'm going to look at the top. The top of this is how many square units? 2. So I have 2 times 2 because that side and that side are the same. That equals 4. Right, double that equals 8. And then I'm going to have this side that I haven't calculated. This side is 6 square units because it's 1 by 6. So I'm going to do 6 times 1 equals 6 times 2 equals 12. And then I'm going to add these numbers together. 24, 8, and 12. 8 and 6. 8 and 4 make 12, 13, 14, so I have 44 square units. Because I found the area of each side of this, and then I added that together. So this asks us to draw our figure on these isometric dots. So I need to draw a 6 by 2. So what I'm going to do is I'm going to connect, that's 1, 2, 3, 4, 5, 6, and it's gonna go back like 2. There's the top, there's sort of the top of that, and then it's gonna go down 1, 2. It's gonna come up 1, 2. It's gonna go down, it's gonna go across. The same. Right, so you can kind of get how this looks, right? So how this looks on this paper. So what I did is I did 6 units, and so I started at 1 dot and went over 6 dots, and then I went back 2 dots, right? Because it back 2 dots. So this gives you an idea of what this would look like on this paper. Now I might have messed this up because I think I went back too far. Because I think it's supposed to only be 1. But the idea is that you're connecting the dots here. So that's my mistake, so I'm going to try that again. I should go 1, 2, 4, 5, 6. So here's should go back sort of like this. So better drawing, but you get the idea here. And then so we have 2 vocabulary words from our unit on Friday from surface area. It's surface area. Surface area, I know you can't see this. Surface area is the number of unit squares it takes to cover all the surfaces of a 3-dimensional figure without gaps or overlaps. The face is any flat surface on a 3-dimensional figure. All right, so that was from Friday. So if you have any questions, just please come to tutorials and we can chat.